The title of the presentation is quite a mouthful. Possibilities of Russian integrated geographically distributed information system, TETRIS, to supply consumers of Earth remote sensing data. It's supposed to be something quite fun to listen to, because to provide a lot of data by cables, this is a real challenge. Yes, hello once again, dear colleagues. So it happens that I'm entering this stage now, considering that Vladimir Romashkin fell ill, and he is the one who comes from very serious company, the Research Institute for Precision Instruments, and his colleagues spoke here about the use of remote sensing data for the interest of big data processing and creation of mosaic tiles and coverage, considering that the development and modernization of the system that Mr. Romashkin wanted to talk about is handled by the state corporation ROSCOSMOS, and it is done upon the instruction from ROSCOSMOS. I will briefly tell you about the general idea, what the system was originally invented for, where we're going with that, considering, again, the story from the morning about the project called Digital Earth, because everything is interconnected. It tells you a background story, what was there in the beginning, what we have now, specs of the satellites. Again, we didn't agree on our two presentations with Mr. Romashkin on radar satellites, and this is the system that he wanted to talk about. The state corporation ROSCOSMOS pays special attention to the development of on-ground aerospace infrastructure for reception, processing, archiving, storage, and distribution of the Earth remote sensing data. And now we also provide products and services based on that. So this is, if you will, an expanded term of this system. It is called ERS, DZZ in Russia, with this well-known system, which consists of a number of components. And already today, I mentioned the first component, which are the reception centers, shown on this slide. I told you a story about them already. I just wanted to add that aside from the innovations that we have developed in 2018, when we had Arctic zone covered by all the reception centers in Antarctica, Cuba, our idea for the following years, first of all, is to connect to the system, first of all, Spitsbergen. This is a well-known global scientific center of reception. This system and their distribution in the best interest of meteorological survey. Russia is present there. They have two of our stations there belonging to Rosgidromet, to be exact, to Institute of Arctic and Antarctic. And now, on the sidelines of the Antarctic Arctic State Council, we have agreed with the Institute of Arctic and Antarctic that these two reception facilities developed by the Kongsberg Norway company will be connected to ERS, and it's a done matter. We have reached a preliminary agreement about that, and next year, Spitsbergen, two Russian reception stations from the meteorological constellation of the whole world will be included into the ERS DZZ. We have also agreed that if the country that Spitsbergen belongs to, we can use that territory to place our Russian Arctic station to receive data from all the Russian satellites, but we'll also share or provide services of data reception from all satellites working in X-band, L-band, which download information from their national constellations. Besides, our next step today, considering the development of the Far East area of Russia, together with the Ministry of Emergencies of Russia, we have decided to include into ERS system the center located on the territory of the Ministry of Emergency Management. They have Scanex station. We will assume the ownership of that, and together with the Far East University, we will establish a single information reception center for the Far East of Russia. Of course, we don't really need it there because Khabarovsk Center and another center cover all the reception areas, but the creation of this center on the territory of DFFU, the university, will help us solve the problems of an innovative educational center of ROSCOSMOS. And again, together with the Far East Development Agency, we shall have established on the Ruski Island a scientific, educational, and engineering center of the state corporation ROSCOSMOS. So on the eve of the next session, where Olga is going to tell you about the interaction with the educational facilities, I can report to you that this is the kind of idea and project we have. Then, a long time ago, 3 years ago, we established a similar center based on the Kursk State University, the Western Federal University. In Kursk, there we have an antenna, a reception antenna, and all the students can receive remote sensing information and use it for educational purposes. Besides, again, expecting the question from Olga Gershenson, I can say that we actively work with the Sirius Center. At the next session on Live Earth, we'll be doing with Sirius. So be mindful of that, Olga. A few words to tell you about how, before I do that, that information infrastructure, first of all, is designed for reception, for planning of space imagery and acquisition. There are two segments. It shows how the constellation of satellites covers the area in 5 days, the territory of not only Russia. And here we show the United States as, in fact, how the whole territory of the whole world is covered. And reception facilities can be different in their parameters, and now they are represented by a series of products from 3 to 6 meter diameter and to 9 to 11 meters diameter of the reception stations located, as it was shown, all over the world. Requirements to radio lines. The high-speed radio line of the satellite and the ground-based radio line that ensures the reception of data. If you see that now resource P works with 300 megabits per second, 2 channels for 150 each, next 2 satellites, 4th and 5th, to replenish this satellite will have 600 megabits per second. Similar radio line will be installed on Observer R radar, satellite 600 megabits per second. But onwards, Condor and RBKS that I mentioned today, we shall have a line for 1200, 2400 megabits per second. The speeds are going to grow almost tenfold compared to what we have at the moment. And the requirements to the reception complexes and demodulators will grow together with that. A few pictures based on the Ministry of Emergency Center, the Rescue Center. They have 2 reception facilities developed by RKS, but 6-meter diameter. They receive all the data from all satellites, Russian and foreign ones, that transmit information in X band. Antarctic. It's also our pride. And within a short period of time, with the Institute of Arctic and Antarctic, we have established a reception center which was put into operation. This is what it looks like at totally automatic control there. They have only one person there from the Russian Antarctic expedition who throws the switch. That's it. Everything else is done fully automatically. Reception and transmission of information through rebroadcasting satellite, and then they keep information on Antarctica if they need it for Antarctic expedition purposes. But I think this is a huge thing that we can be proud of. And the idea of creating the center in Antarctic was born about 5 years ago when we visited India and they showed their system. And right from their center, Earth remote sensing center, we communicated with a similar center located in Antarctica, but Indian part of Antarctica. Now 3 countries have such centers: India, China, and now Russia. So I guess it is very important, ever more so, that when we have a system of rebroadcasting array which allows us to get all the data that we acquire in Antarctic and in Arctic centers in Dudinki and Valeriy to broadcast them in real time to Moscow. This is the station located in Dudinki. It is under the dome now. Against the inclement weather conditions, and these are the traditional Russian stations. Our separate matter of pride is the mobile reception center. It is part of ERS, and now it is an element included into the operation for our operator of Earth remote sensing. It's made up of 2 containers. We created upon the special order from the Ministry of Emergency of Russia, and we have agreed with the Ministry of Emergency Management that tomorrow we'll start its joint operation, and as early as in March next year, this mobile complex will go to Yakutia, specifically to quickly receive information for the interests of fire control, flood control. Why Yakutsk or Yakutia? Because in March, April, that's where the river Lena suffers from floods and congestions. To make sure that the Ministry of Emergency uses this information, we have agreed with the Ministry of Emergency Management to do it by then. Data storage. We spoke about this today. We heard about the experience of data storage from XR and Airbus. Now we're moving along the same path. We are establishing a National Earth Remote Sensing Center of Russia, National Center of Russia. It will have a distributed infrastructure. The principal office will be located now in NITP in Otradne, where we have the Scientific Center of Earth Monitoring Center, our operator from ROSCOSMOS. And as of March, we'll start the construction work. It will be a building like in Suks, like the National Defense Center, with a situation center, a good, decent National Earth Remote Sensing Center building, who would be proud to invite our foreign colleagues, the Russian president, and so on and so forth. And again, as we are planning, it will be equipped to the cutting-edge technology. We'll have one of the data processing centers installed there, storing the first copy of the federal Earth remote sensing database. Second copy will be stored in 800 kilometers from Moscow in Kalyadin, where we have the remote space communication center, based on which we are building the National Earth Remote Sensing Data Center, and there will be backup storage for our data. And the third one on the territory of RKS. So we're talking about double backup to make sure that we do not lose this data, which in real time will be communicating with each other. And that's how we'll have a synergy between them.
Русско-английский текст, но тем не менее.
This is a Russian-English text, but it shows a single processing center that we're establishing in Russia. In order to make data processing automatic, the Precise Instrumentation Research Center is pursuing the following task. We do processing of L0, L1, L2, L3, and 4 by way of synthesis. So it gives us products that will be loaded onto the cloud, so that users will not see the processing itself. So we will reduce the time needed for users to access standardized products. Here we see the principles of such processing, the way it takes place in the world. But this is a new activity, part of modernization plan to develop remote sensing data reception infrastructure. And the most important question is to provide access and distribute data, which is in our primary focus. So it's of critical importance what we discussed in the first session. This is our aspiration. I think starting 2021, as part of the Digital Earth project, air quotes, Digital Earth, we will have established services that will enable domestic users not only use data, but also data-driven information products. To ensure access to that data, to those products, we have a geoportal, ROSCOSMOS geoportal, that has been in operation for a dozen of years, offering services of respective levels. Even today, you can get online and receive some of the products in an automatic mode. I think it will be a good closure to my presentation. I just want to say, as a final note, that the Digital Earth project implemented in the Research Institute, Precise Instruments, is a follow-up to this single window or one-stop shop principle for all the services. Thank you for your attention. I think I made it right on time. Yeah, it's working. We have 1 minute to spare for questions. Valeriy, this complex that you want to set up in Yakutia, how much does it weigh and who will be maintaining it? Since we prepared it for the Ministry of Emergencies, we're going to use it by using Il-76 freight plane that will deliver 2 containers. Then it will be offloaded on trucks, mass trucks. Then the deployment time is about 6 hours. Only 1 man is doing maintenance. I mean, getting it ready for operations. In fact, it's in automatic mode. As for receiving data, it depends on the amount of data we expect. I think it could be 2-3 persons who would be sitting in the second container where we do thematic processing. I also have a question. So you receive initial data from satellite imagery. Are you planning to process and store all of it, or process only per request basis? It's an interesting question. I showed you a slide with raw data. So we receive raw data. We divide it into smaller portions, and we store raw data. So as soon as you enter the database, you will have access to that raw data. I mean, we don't store it in a processed fashion. Users have to log in and request what they need. But there will be some wait time, right? Yes, there will be some time you'll have to wait. We use the automatic data processing system, and then regardless of the source of data, meteor resource or the future satellites imagery will follow the same principle. Well, good luck with that. I mean, sometimes customers do need raw data to run detailed analysis to extract some information which we are incapable of extracting. So we just hand over raw data to them. Are you planning to do the stitching as well, some mosaics or plans? Yeah, and all of that will be performed online. Yeah, well, good luck with that. We'll do our best. And ROSCOSMOS will help us out. I have my hopes on that. Thank you very much.